Hello friends, today we will talk about chemical kinetics of reaction. So let us go through one by one. The first one is zero order reaction. So basically, as we all know, that a reaction in which rate does not vary with the increase or decrease in concentration of reactant. So if I take any general reaction like A reacts to give products, and if I write the rate of reaction for zero order reaction, so it is also represented as R. So I can write K, and since it is zero order, so I will write 0 over here. Okay, so when any power is raised to 0, the value becomes equals to 1. So basically rate of reaction will be K, because a to the power 0 becomes 1. So this is the expression which we can write with respect to rate of reaction. Also we can write differential rate equation. Also zero order reaction can be written as minus dA by dt with respect to this reaction. So basically this is the first equation, this is the second equation. Both of them represent the same thing. It means minus dA by dt is equals to k into a to the power 0. So basically when we integrate these two, dA by dA with powers of a naught and a, and this dt comes to this side, so it becomes minus k dt, and when we integrate it with respect to 0 and t. Why? Because when time is 0 means reaction has not started yet. So at that moment when time is 0, when reaction is not started, at that moment whatever concentration we have is initial concentration. Okay, so I'm not going into the detail how to derive this one. So basically the conclusion that we get is integrated rate law, like a is equals to a naught minus kt. This you have to remember because this is very important. This is integrated rate law, integrated rate law for zero order reaction. Zero order reaction, this expression is very important. Okay, so I will derive various conclusions from this equation. So the very first thing is we need to know how to plot a graph. So graph of concentration, basically graph of a concentration versus time. So if we have to plot a curve between concentration versus time for zero order reaction, so write this equation in such a way that a is equals to, I'm rearranging this equation, this will be minus kt plus a naught. Okay, so compare this equation with a straight line equation. So y is equals to mx plus this becomes, this becomes c. This is plus and this is c. So when we plot curve, if I plot a curve, okay, so if I take the time on this axis, time here, because this is y-axis and this one is x-axis and this one is y-axis. So with y-axis I'm taking a, so this is concentration axis, and with the x-axis I'm taking this t. Okay, so now compare these two. So basically on y-axis we have a, at x-axis we have this t, and what is the value of c? C is basically constant, this is called intercept. So this is some positive value on y-axis, so I can write from any point. So now this point will be a naught because this is the constant value. Okay, so whatever angle this makes with this axis is going to be theta. That's what we call as slope. Okay, and now what is the value of slope, because this question is important for multiple choice. So what is the value of slope? M is called slope. What is the value of m when we compare with this? This is minus k. So this you have to remember. For a zero order reaction, when we plot a curve between concentration versus time, the value of slope m is minus k, and this line also represents negative slope. Okay. A second important thing that you should know from this equation is half-life of a reaction, zero order reaction. So it is also represented as t half. So how to write this one? Again, I will refer to the same equation that we have already studied, is this one. A is equals to a naught minus kt. A is equals to a naught minus kt. So basically, when we are calculating t half, so this t is going to be t half. That means at t half, what a will be, a is what, remaining concentration. So at t half means half-life concentration is, remaining concentration is going to be half of the initial one. So this we have to put these two values in the equation. Then basically we can write at t half a becomes a naught by 2. So for this, from this equation I will write a is what, a naught by 2 is equals to a naught minus k. Now this t is what, t half. Now rearrange this equation. So I can write it as k t half is equals to a naught minus a naught by 2. So a naught minus a naught by 2 is what, a naught by 2. So basically what I can write is k t half is equals to a naught by 2, or directly I can write t half is equals to a naught by 2k. Again, this is the second important expression that you should know. This equation represents half-life of a zero order reaction. Okay. One more thing, if I need to find, although it is not required for Miss NCRT or CBSE, but you should know lifetime of reaction, lifetime of zero order reaction. Zero order, what is lifetime? Lifetime means when reaction gets complete. So at t is equals to t 100%, yeah, lf I can write. What will be the remaining concentration since entire reaction is complete? So at that moment a will be what, 0, because entire reactant is going to be consumed. So again I will refer to the same equation. A is equals to a naught minus kt, integrated rate equation of zero order. So at t 100%, a becomes 0. It will be a naught minus k t 100%, means lifetime. So you can write t 100% is equals to what, a naught by k. This is the lifetime of zero order reaction, and you can compare these two equations. So basically half-life is a naught by 2k and lifetime is a naught by k. That means just double of half-life. That's why we say in zero order reaction unitary method is followed. Unitary method means if 50% is 50% reaction is completed in 5 minutes, so 100% will get completed 10 minutes. If 50% is completed in 4 minutes, it will take 8 minutes, like that. If lifetime is 50 minutes, so half life will be 25 minutes. Yeah, so in that way means unitary method is followed, and this is again we have proved this one, how unitary method is being followed. Okay. Second thing that you should know, very important, is again graph of t half versus initial concentration, means a naught. So again, every time when you have to plot the curve, you have to refer to the equation. So what is the equation of t half for zero order reaction? T half is equals to a naught by 2k. Okay, so now again compare these two. We have to plot the curve between t half versus a naught. So I can write same way we can write y is equals to mx plus c. Here we have plus 0, so that means intercept is going to be what? 0. Let us plot the curve. Okay, so now on y-axis we have t half. So on y-axis I will write t half. So this is the axis of t half. On x-axis what we have? A naught by 2k. So on x-axis I will write a naught. Now what is the value of m? This is important. So when we have taken a naught as x, so what is remaining? 1 upon 2k. That means 1 upon 2k is going to be your intercept. But since this intercept is positive, also one more thing, what is the value of c? Since it is 0, that means no intercept. So it is 0, that means line will pass through origin. And what is the value of m? M is going to be 1 upon 2k. Okay, so in this way, means these two things are important for zero order and first order reaction: how to plot the curve and how to calculate the value of slope. What is the value of slope? These two reactions are important. Again, quickly I will start with first order kinetics. First order reaction, and let me tell you, means 99% chances are there that you will get first order reaction only in the exam, in every exam basically. So again I will write the same reaction general equation when A reacts to give product. So in this case we can write rate of reaction as k. Now since this is first order, so it varies, means power is raised to be 1. Also second part we can write the expression as minus dA by dt using the differential rate method. Okay, so again I will, since these two values are equal because they represent the same thing, so I will put them as equal. So this will be dA by dt, and this is again negative sign I have transferred to this side, so this will be k dt. So again when we integrate these two terms, rearranging them, basically the final ultimate outcome I'm writing, what we get is a log base e. This is very important, log base e, not 10. Right now this is log base e. So log base e a is equals to log base e a naught minus kt. This is the integrated rate equation for first order. Can you compare with zero order? Yes, the same type equation we get. A is equals to a naught minus kt. So see this one, a naught minus kt. That means a similar equation we are getting in zero order also, but the only difference is we have log exponential attached to it. Okay, so now the thing is, when we change log base e to log base 10, so we have to multiply it by 2.303 in order to convert it to log base 10. So the moment I convert it to log base 10, I need to multiply this entire equation by 2.303. This will be 2.303. Now I will write log base 10 a is equals to log base, no, I should multiply it. So this will be 2.303 log base 10 a naught minus kt. Because there is no log, so we don't need to put 2.303 here. Wherever we have log e, that has to be multiplied by 2.303. Now what if I divide this equation? Divide by 2.303. So when we divide this entire equation by 2.303, we get log base 10 a is equals to log base 10 a naught minus kt upon 2.303. Okay, this is the final equation, and this is called integrated rate law. Integrated rate law for first order reaction. We can also, we can rearrange it. But again, I will first make you how to draw the graph. So if I need to plot graph between graph between log a versus time, graph between log a versus time. So again, make this curve. Okay, so write the same equation again. Log a is equals to, I'm rearranging this one, so it will be minus kt by 2.303 plus log a naught. Now compare these two with the straight line equation. Y is equals to mx plus c. So what is the value of c? Log a naught. That means some positive value on the y-axis. So on y-axis we have log a on y-axis. On x-axis we have mx. So on y-axis I'm plotting t. So this will be t. Now what is the value of m? You can clearly identify minus k by 2.303. This question comes in multiple choice. Many times this question has appeared. So intercept value, now what is the value of c? C is log a naught, so some point on the log a axis. So again this will be like this, negative slope. So what is the value of slope? M is equals to minus k by 2.303. This question is again very important for a first order reaction. Okay, now there are various other forms that are very important for your to solve numericals. Other forms of equation, you can write exponential and other forms are there, but the most important one that is used in solving the numerical is t is equals to 2.303 by k log, again now it is base 10 only, so it is a naught divided by a naught is what? A naught is initial concentration. Okay, so in some books it is also written as 2.303 by k log base 10. A naught is initial concentration, so they have written it as a, and a is remaining concentration, so they have written it as a minus x. So both of them are same, they represent the same thing. That means initial one is has to be in the upper side and the remaining one is at the denominator. Okay, so these are the important equations that you should know in order to solve any equation. Now most important part is half-life of first order reaction. First order reaction. So to solve each and everything, what you need to know is the integrated rate equation. So what is half-life? Half-life is basically time in which reaction completes by 50%. Okay, so at t is equals to t half, means when time becomes half of the initial one, the remaining concentration is half of the initial one. So this is means common phenomena in every process. So write the integrated rate equation. T is equals to 2.303 by k log a naught, means initial, by remaining. So at t half, if I write it as t half, this will be 2.303 by k log a naught is written as such, but a remaining concentration is what? Half of the initial one. So I will write it as a naught by 2. So basically a naught gets cancelled out. We remain with log 2. So t half is equals to 2.303 by k. Then we have what? Log 2. The value of log 2 is 0.3. So t half is equals to, when we multiply 0.3 into 2.303, we get 0.693 by k. So this is the t half and this expression you have to remember 0.693 by k. This is the value of half-life of first order reaction. Again, I will add one more thing. What is lifetime? Lifetime of first order reaction. Lifetime means when reaction gets complete 100% completion. So at t is equals to t 100%, what will be the remaining concentration of A? This will be 0. A is going to be, means concentration of A will be 0. So now put this thing into the equation. We have 2.303 by K log A naught by A. Okay. Now since at t 100% A is 0, so if A is 0, that means this value is going to be 0. So when you divide anything by 0, what is the outcome? So t lifetime or t 100% will be, when you divide anything by 0, it becomes infinity. That means first order reaction का lifetime infinity. That means very important conclusion, you can note it down. A first order reaction never completes, and yes, it is true, reaction never completes to 100%. फर्स्ट ऑर्डर रिएक्शन कभी कंप्लीट नहीं होगी. This you have to remember. Now there are several graphs there are many graphs, around 6 or 8 maybe, but I will discuss only 2 or 3 of them. Okay, the first one is rate versus concentration. So if I plot rate versus concentration, so first plot is rate versus concentration. Every time you have to remember the equation. So rate of reaction is what? Just simply I can write it as rate is equals to K into A. This is the first order equation. Okay, so compare this equation by y is equals to mx plus c. So plus c we have 0, means no value of constant. So this, of course, this line will pass through origin. But what will be the value of m? So m is k, that means positive value. So it will have a positive slope. On this x-axis, what we have? We have a. So on x-axis we have a, on y-axis we have rate. So when we plot the curve between rate versus concentration, this is the slope that this is the curve that we get. And what is the value of m? Value of slope is k, rate constant. Very simple one, straightforward. Second graph that is very very important is log A, of course, base 10 versus time. Log base 10 versus time. So plot this curve and first write the equation. What is the equation for first order reaction? So when we have to plot a curve between log base 10 versus this, again this we have already done, but let us revise. Log base 10 A is equals to minus kt by 2.303 plus log a naught. So when we plot this curve, this is the x-axis, this is y. Compare this with y is equals to mx plus c. So on y-axis we have log a on y-axis. On x-axis we have t. So this is simply time. What is the value of k? This is minus kt by minus k by 2.303. That means negative slope. What is the value of c? C is log a naught. That means some positive value on y-axis. So again, but negative slope. So this is the negative slope. And what is the value of m? This is minus k by 2.303. Okay, and the third plot that I will discuss is very very important, is half-life versus initial concentration A naught. So whenever you have to plot the curve, you should know the relation between them. So write the expression for T half. T half is equals to 0.693 by K. 0.693 by K. So again, if we compare, if I compare this, so this will be y is equals to mx plus 0, so I can write plus c. So value of c is 0, but again see, this is T half, this is A naught, but in the expression, in this expression of T half and rate constant, there is no term of A naught. That means A naught has no connection with T half. So if I plot this curve A naught and versus T half, so since A naught and T half, they are not connected, they have no relation between them, so what we get is a straight line. That means initial concentration is independent of the half-life. This conclusion is very important. Okay, now I will make you write several although these are the questions, but you can write them in form of note or general means these are the formulas. First one is for first order reaction, of course, for first order reaction. But these are the questions means CBSE might ask to prove this relation. But the first one is T 75%, या इसको 3/4 भी लिख सकते हैं, 375% is 2 times of T half. Second relation is T 99.9% is equals to 10 times of T half. Third one is T 25% is equals to 0.415 times of T half. And the fourth one is T 87.5% is equals to 3 times of T half. These are the formulas, very important relations. Okay, so let us solve one question which I think is going to be very important for board exam. Okay, so if I write the first one or second one, I can take any one. So prove T half, we have to prove that T 75% is equals to 2 times of T half. So you don't need to put the values, that is the very basic thing. Okay, so first write T 50%, yeah, T half. So when we write T 50%, that means 2.303 by K log, what is initial concentration? So take it as 100. T 50%, that means 50% reaction is complete, so what is the remaining? 50%. So this is the first expression. Directly write T 75%. So this will be 2.303 by K log, again initial one is 100. So if reaction is completed by 75%, that means remaining one is 25. Now divide these two equations. Divide 2 divided by 1. So what we get is T 75% by T 50% is equals to, basically these two values are, they will cancel out each other. This is log 2 and this is log 4. So this will be log 4 divided by log 2. Log 4 can be written as log 2 square, and log m to the power n is called log m log n. So I can write it as 2 log 2, and this is already log 2. So log 2 cancel out each other. That means T 75% divided by T 50% is equals to 2. That means T 75% is equals to 2 times of T 50%. So when you are putting these values, that means you are making it complicated. Okay, second part. If I have to prove the second relation, that means T, this is very important. I think for this year, T 99.9% is equals to 10 times of T half. So again write expression for both of them. So T 50% is what, 0.693 by K. This we already know, this is the formula for T half. This is the first equation. Right, for T 99.9%, 99.9%. So this will be 2.303 by K log. Initial concentration is 100. Now, if reaction is getting completed by 99.9%, that means whatever is left is 0.1%. Okay, so when I rearrange this one, so it becomes T 99.9%. This will be equals to 2.303 by K, and remove this point, so this will be log 1000. Okay, that means T 99.9% is equals to 2.303 by K, and log 1000 is 3. Value of log 1000 is 3. So T 99.9% is equals to, so when you multiply 3 into 2.303, the value is 6.909 by K. Okay, now this is the second equation, and again divide second by first. So what we have is T 99.9% divided by T 50% is equals to 6.909 by K divided by 0.693 by K. So K cancel out each other, and this is exactly 10 times. So what we have is equals to 10. That means T 99.9% is equals to 10 times of T half. Hence proved. So in this way you can prove any question, but these are the formulas also. Thank you.